Hey guys, this is Mohamed again, and we'll be going over Math 131, Quantitative Literacy, Math for the Modern World, Chapter 4, and this chapter is about personal finances, interests, monthly payments, and investments, and all that stuff. Basically, we have a set of questions. Whoops. We have a set of questions and we will solve them together. Okay, so it's 8 pages. Okay, so starting with the page number, problem number 1, we have an initial amount. Problem 1, we have an initial amount that's equal to $5,000. And it earns an APR of 7%. And we want to find the doubling time. So how many times, how much time for the investment to double in value, whether years or months. So, and a keyword here, they wanted us to check approximately. So you can use what we call the 72 formula. Basically, so the doubling time, that's equal to 72 divided by the APR as it is. You don't divide by 100 in this formula. So simply, this is done, of course, for quick calculations. 72 divided by 7. We go here. Clear. So 72 divided by 7. The answer is 10.28. 10.28. And the answer is in years because this is an annual. So this is an annual percentage rate. So the answer is in years. So simply C is your answer. Now, this is the approximate method. What if you want to find the accurate method? So, accurate method, doubling time, that's equal to log 2 divided by log 1 plus R. Big disclaimer, as we say always, R is equal to APR divided by 12. It's a percentage. So it's equal to 7 divided by 100 divided by 12. So 7 divided by 12 divided by 100. The order is not important, only in this case. So 0.005833. 0.005833. So my time is log 2 divided by log 1 plus R is equal to 1.005833. So log 1.005833. So I go to my calculator. I clear everything. Log 2 divided by log 1.005833 log equal to 119.12. So the answer 119 point something, but this is in month. So again, I have to divide by 12 to get the answer in years, because this is what my answers are about. So divide this answer by 12, and the answer is 9.93. 9.93. 9.93 years. So that's very close to 10 years. So method 1 or method 2 gave me the same answer. Perfect. Ignore this question 2 because I don't have a graph for it. I don't know. It's probably a typo. We move to question 3. If you need to borrow 36,000 for, so number 3. If you need to borrow 36,000 for 2 years, approximately how much should you expect to pay each month? So I have initial amount. That's 36,000, and I have the term is equal to 2 years, and I can immediately say it's 2 times 12, it's 24 months. Now we want monthly payments, but if we remember, we always need the amount, the dollar amount, we need the terms, but we need the interest rate. I don't have R, I don't have APR. So what should I do? I don't have them. It's time for assumptions. Okay, so assume R is equal to 0. So there is a payment of $36,000 that you borrowed, and you have to return for 24 months. You assume simply that there is no interest, zero interest. So if you were to divide this payment by the amount of months in a linear fashion with no interest whatsoever, the monthly payment is equal to 36,000 divided by 24, and that's 36,000 divided by 24, and that's 1,500. Now $1,500 per month if you have zero interest. Now usually it doesn't say, the problem does not say zero interest, it simply does not give us the interest, right? So what we have to do, we have to assume even if the interest is 1%, most likely we'll end up paying 1,500. So if there is interest, the payment will be $1,500 per month plus some interest, even if it was pennies, like let's say $0.01 per month. Even if this was our interest, the answer would be our payment is a little more than 1,500. So that's my answer. Make sense? Okay, moving on. I really have to plan with this. Okay, moving on with my questions. Now this is a little bit tricky because, again, if we have all the numbers, all the input, it would be easy. You just plug in the formula. If you don't have all the numbers, you need to use some common sense. You need to use some critical thinking, and this problem definitely needs it. So suppose you want to purchase a new car for $25,999. So let's say for simplicity it's 26,000. Okay, and you're offered 0% interest on a new car loan. So you have two options. You have option 1, 0 APR, but the amount is 26,000. Option 2, you have an APR greater than 5%, and you have cash back, or you have $4,000 cash back. So this will make the initial cost or the price basically will be 26,000 minus 4,000, so that's $22,000. So I have two options. I should compare them. Either pay 26,000, zero interest and price, or pay a lower price but you have an interest occurring and we don't know how big is the interest. So the main question is, if you save 4,000 on the price of the car, definitely less, this is 4,000 less, would you be paying more than that in interest? That's the real question. And in order to answer, of course there's some ambiguity. They did not give us any of these inputs. We don't know the APR, we don't know the term of the loan, we don't know if there's a down payment, and we even don't know the monthly payment. But it's a qualitative question that's asking us which factor is basically more influential in the decision. So I did some calculations, and it is not a straightforward question, and I'll show you why. So what you have to assume first, so first of all, we don't know the APR, and we don't know the interest, and we don't know the terms. So we have to assume an interest, assume APR to be equal to 6%, for example, because this is what it says. It's going to be greater than 6%. And we have to assume a certain term. Let's say 5 years. Now, I'm trying to see if the APR is the most decisive factor or if it is the term of the loan. Okay? So the way I do this, I have to make another assumption. So I have to assume APR to be 6%, and I will do terms 5 years, I will call it term 1, or term 2 would be 6 years. At the same time, I assume another APR, call it APR 2, assume it to be 7%, and check my results for term 1 and for term 2, and see, increasing the APR by 1%, was it worse than increasing the term by 1 year? So I hope that I'm making myself clear. You have two knobs that are turning. Imagine you have a knob that you are turning. One of them says APR. So it goes from 0 to 5% to 6%, for example. And we have another knob that says the term. It goes from 5 years to 6 years. Now, they're asking you which knob that you turn that will cause a greater payment. So maybe the term going from 5 to 6 to 7, it's not that much. Maybe the APR going from 5 to 6 to 7, maybe this will be a bigger impact. So they want us to study the impact of the APR and the term, because the down payment could be a factor, and the monthly payment, the monthly payment depends on the APR, and that's why I wouldn't study this, I would study this. Okay, so what I need to do, back to my assumptions. So my 0, so let me do the easy one first. If interest is equal to 0. Monthly payment. Okay. I will do the 5 years. I'll do 6 years. I'll calculate monthly payments. This will be simply 26. So the amount, if interest is 0, amount is 26,000. This is what we agreed on. This is we're examining this option A. Let's call it option A. So the payment will be 26,000 divided by 5 times 12. So this is 5 years. And in this case, it will be 26,000 divided by 6 times, whoops, my 6 is messed up, 12. So 26,000 divided by 60, 433. Dollars. Now this is 26,000 divided by 72. 26,000 divided by 72 is 3361. Of course, 12 times 6 is 72. Okay, so this is my monthly payments if I did not have any interest. But I do have interest. So if interest is equal to 6%, my monthly payment, I have to use that ugly formula. Okay. So monthly, is this an APR? It is an APR. So interest 6%, so R is equal to 6% divided by 12, which means 6 divided by 12 divided by 100. 6 divided by 12 is half, 0.5. Divided by 100 is 0.005. So monthly payment is equal. Okay, I have the formula open in front of me. It's amount borrowed. Now remember, if I have an APR, the amount borrowed is less. I'm studying option B. So 22,000. 22,000 multiplied by R, 0.005 multiplied by 1.005, 1 plus R raised to the power T, divided by 1 plus R raised to the power T minus 1. Now remember, we're testing two terms, 5 years and 6 years. Now, just as a heads up, the answer for this is that the term of the loan is the most effective factor. So you will see that the APR has some effect, the monthly payment has some effect, but it's the term of the loan that's the most influential. So even if you have a lower interest, but you have a higher term T, because this is exponential, so it's gonna be a crazy number. So that's the insider, and that's kind of the information that I wanted to make clear. So this is T, this is 1.005. So I'm gonna need this calculator in front of me. 1. Oh, so I have two T's, right? I have two terms, 6 years and 5 years and 6 years. For 5 years, I have 1.005 0.005. Whoops, I added a 0. Shoot. 1.005 raised to the power 60. What's wrong with me? Okay, multiplied by 0.005 multiplied by 22,000. So the numerator $148.373. Denominator 1.005. Whoa. Raised to the power 60. Okay, my pen is messed up. Minus 1. So I have 1 over this guy. Okay, so that's 0.3488. So I have 1 over answer multiplied by 148.373. So the monthly payment now is $425. 4 years. For 6 years, evaluate the monthly payment again. I know it's a lengthy problem, but we need to solve it. So same interest, same everything, plus t is different. Okay, 1.005 raised to the power. So 6 years is 6 times 12, that's 72 months. Raised to the power 72 multiplied by 0.005 multiplied by 22,000. That's 157 divided by 1.005 raised to the power 72 minus 1. That's 0.432. 157 divided by 0.432. That's $363.426. Now, which one is better, the 425 or the 363? We will realize that the way we tell is we should calculate the total payment. So let me calculate the total payment in a different color. Whoops, my computer is not behaving well. Okay, so total payment, that's equal to 425 per month multiplied by 5 years by 12 months, that's 60. Okay, so 425 multiplied by 12 multiplied by 5, so that's $25,500. Whereas for the 6 years, the total payment is equal to 363.426 multiplied by 6 years by 6 by 12. So 363.426 multiplied by 6 multiplied by 12. Wow, 26,166.72. Now, what do you notice here? My zero interest payment was total was 26,000. My interest payment with 5 years was less than that. My interest payment for 6 years was more than that. Oops, yeah, this one. So it showed me that the effect of the term just increasing from 5 years to 6 years had a drastic change on the total payment. So as a general rule in all of these problems, you should always, the criteria that you should build your judgment on is, what's my final payment, and am I saving money or not? So here you are saving money. You are paying less than 26,000. You are paying 500 less. Here you are actually paying more. So technically it's not a good idea. So you see that the term of the payments between, so the term of the payments had a greater effect more than the monthly payment. The monthly payment is irrelevant. The term is actually was really a big deal. Now, how can I confirm that it's the term and not the interest rate, the APR? I basically have to calculate the other case that I mentioned, which is the 7%. So I should do it for both, for the 5 years and for the 6 years. I'll do it quickly, and I did it before I record this video, and it turned out that the term has a bigger influence than the monthly payment. So let me do this here, different color. So now I hope that you guys, if you guys are confused, please try to go back in the video to where we started. So now I have term 1, 5 years. Term 2, 6 years. I'm using APR 2, which is 7%. Okay. So I need to use the same monthly payment formula. So monthly payment that's equal to amount multiplied by R multiplied by 1 plus R raised to the power T divided by 1 plus R raised to the power T minus 1. The amount is 22,000. Oops, I hope that amount is 22,000. Because remember, if we go with the payment, we're exploring this. Okay. So monthly payment for 5 years, 7% APR, that's equal to amount 22,000 multiplied by R. Let me calculate R. Oh. 7 divided by 12 divided by 100. Okay, so that's my R. Let me do the 1 plus R, the difficult. 1 plus R raised to the power T. My T in 5 years, that's 60 months. multiplied by R 0.0005833 multiplied by amount 22,000 181.92. I'm approximating. So divided by 1 plus R raised to the power t. So let me do R again. 1 plus 0.0058833 raised to the power t, which is 60 month minus 1 0 4176. So divide by this, multiply by 181. Whoa, my monthly payments was $435. Doesn't seem to be a big influence, so technically I can stop my calculations now. So it was 425 for the initial percentage. So this was APR 6%. So it's not a lot of difference. Now monthly payment, six years, which means 72 months, 7% APR. We're almost done, guys. Apply the same formula, the same ugly formula. 22,000 multiplied by R 0.005833. Of course I memorized it. Multiplied by 1.005833 raised to the power 72 195. Now I should do 1 plus R 1.005833 raised to the power 72 minus 1 0.52. 1 over answer multiplied by 195, $374. Now time to calculate total payments, because remember, I don't care about monthly payment, I care about total payment. So technically the monthly payment answer is definitely wrong. You don't care about the monthly payment, because what matters is how much you're gonna pay total and how much you're gonna pay in interest. So it's basically in between these two. We were testing the term of the loan or the APR. So use a different color. Total is equal to 435 multiplied by by 60. 435 multiplied by 60, 26,100. Okay, total here is equal to 374 multiplied by 6 by 12. So 374 multiplied by 6 multiplied by 12, 26,928. So now let me build the matrix, and yeah, I mean the matrix, the movie, because it's very complicated. I have terms 5 years, 6 years. I have APR 6%, 7%, and I want to know which one is more influential. Is it the term or it's the APR? 5 years, 6%. Go back. 5 years, 6%, 25,500. So in this option, I'm saving from the zero interest option. 6 years, 6%. So 6 years, 6 years, 6%. It's this guy here, 26,166. Now 7%, 5 years, is here, 2,600, and monthly payment for the 7%, 6 years is, total payment 26,928. So here's the question: which effect was more? The term or the interest? So from what I see, the term had a bigger effect. So you have about $766 due to term, whereas for the interest, you have between this and this, the increase was $600 due to APR. You can look at also the 7% APR. So from here to here, I'm comparing. So you have 26. I'm subtracting them, guys. 26,928 minus 2,600. That's equal to $828 due to term, whereas here 26,166 minus 26,928, it's less than that basically. So 26,928 minus 26,166, 762 due to APR. So long story short, I compared these and I realized that the term has a bigger impact than the APR. Long story short, this is my answer. The term of the loan affects more than anything else. Okay, now difficult problem, but I mean it's good that we practice this here, and we may not get it as difficult in the exam, but just make sure that you know how to solve these problems. Okay, I'm gonna turn off this video now and continue later. You guys take care. Bye bye.